Hey guys, welcome to my YouTube channel. This is the second episode of sound. Now we'll be looking at time period. A single to and fro motion of a vibrating or oscillating body is called one vibration or one oscillation. So the combination of a compression and a rarefaction create a vibration or oscillation. And here it travels from its mean position to motion from its mean position and back to its mean, and it travels the fro motion from its mean position and comes back to the mean. So in a graph this can be shown like this. Now time taken for one vibration or one oscillation is known as the time period. You can see that the highest point in the wave is the crest and the lowest point in the wave is the trough. So we can find the time period. The time period is between two crests or between two troughs. And you can also find time period which is from the beginning to the end of a single vibration. Now let's move on to the frequency. Now the number of oscillations or vibrations made in unit time is known as frequency. So frequency equals number of oscillations divided by time taken or unit time. It is measured in s⁻⁻1 or hertz. So what this means here is the number of oscillations, which is this is a single oscillation, and this is also another oscillation, and this is the third oscillation, divided by the time taken. So the time taken is from the beginning to the end. So let's consider the time taken is 1 second. Now we know that the number of oscillations is 3. Now to find frequency, we have divide 3 by 1 because the number of oscillations is 3 and the time taken is 1 second, and we'll get the answer 3, and the units hertz we can write like this. Okay. If we consider one oscillation, the time to complete one oscillation is its time period, which means this is a single oscillation, and to complete one oscillation is its time period. Let's consider the time period as 0.1 second. Now, to find the frequency like this, you divide 1 by the time period. So you can find frequency by 1 divided by the time period is 0.1 seconds. So let's write 0.1 and the answer will be 10, and the units hertz. And there are bigger units of frequency such as kilohertz or megahertz. Kilohertz are 1000 hertz or 10⁻³ hertz. Megahertz are 1,000,000 hertz or 10⁻⁶ hertz. They are denoted by this. There are also bigger hertz than these, like gigahertz and terahertz, and so on. Now let's check the time period for sound wave. The time period of the sound wave can be found by measuring the time between successive high pressure points or compressions, which are over here, or the time between successive low pressure points or rarefactions, which are over here. So the time period is between successive high pressure points like this, or between successive low pressure points like this. Let's move on to higher frequency and lower frequency. The frequency is simply the reciprocal of the time period. As you can see here, the lesser the time period, higher the frequency. The more the time period, lower the frequency. You can also see here that in a given time, the number of oscillations is high, whereas here the number of oscillations are low. So according to the formula, we can tell that the more number of oscillations, the higher the frequency. The lesser number of oscillations, lower the frequency. Now let's move on to amplitude. The maximum displacement of vibrating or oscillating body is moved in one direction from its rest position is known as the amplitude. it is measured in centimeter or meter. As you can see here, the highest displacements from its mean position in both directions is its amplitude. So, if a pendulum swings with less force, which means its amplitude is lesser. Whereas if a pendulum swings with more force, its amplitude will be much larger. And you can see here that the highest point in this waveform is 1 centimeter, whereas in this the amplitude is lesser, so it's 0.5 centimeters. Thank you for watching my video. Like, subscribe, hit that notification icon and comment if you like this. Thank you.